Hello everybody, this is our second day of notes in section 3.1 on roots and radicals, and to start today's lesson we are all going to fill out this handout, and it's entitled Numbers I Will Be Responsible For. So we're going to do some of this with a calculator and some of it with our brains, so make sure your calculator is out. Anything that's not in gray you are responsible for, so all of these white boxes we're going to fill out. So I'll do this first row with you and the second row, and then you'll pause the video and finish filling out the rest of the chart, and then we'll compare answers. So the way this works is, here's my first value. So 1 squared is 1. 1 to the third is 1. 1 to the fourth is 1. In fact, 1 to any power is 1. So this entire first row is 1. Now our new base is 2. So 2 squared is 4. 2 to the third is 8, because again, remember that is 2 times 2 times 2. 3 2's multiplied together. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth, and maybe I'm not sure, so keep in mind that that is how many 2's multiplied together. That's 6 2's multiplied together. Or you could think of it, this is 5 2's times one more. So 32 times 2 is 64. And past here, maybe I need to use my calculator. So in my calculator, I would type in 2 and the little caret raised to the 7th. 2 to the 7th is 128. And then again, if I use my calculator here, 2 to the 8th, or I could just multiply this one by 2. Either way, I get 256. So now pause the video, please, and go ahead and fill out the rest of the chart. 3 all the way down, and then when you press play again, this is going to be filled out, and I will scroll down so we can check our answers for the whole chart. So you press pause and I will press pause and finish filling out the chart. So I just finished filling out my chart, so I'm just going to go back up to the top. These are all my squared terms, to the third, to the fourth, and so on. So I'm going to scroll down to this section first and press pause if you need a second to check answers. And I'm going to keep scrolling to check the bottom. How far did that get me? 3 to 10-ish. So here's the next section, or the bottom half. If there's any questions, just shoot me a remind and I can help, or ask me tomorrow in class. But we're going to keep this chart out for today's notes, and this is going to be important for these next couple of days. Let's get into our board notes for today. So when you're ready, go ahead and take out a lined piece of paper, and this is going to be notes on 3.1, simplifying rational exponents. Simplifying rational exponents. And the key word I want us to focus on first is this right here, ratio. Ratio is part of that word rational. What is a ratio? Well, let's remember that a ratio refers to a fraction. That's what a ratio means. Ratio means a fraction. And a fraction, in other words, is a comparison of two numbers. So the rest of this week, all of our expressions are going to have fractions in their exponents. So that's what a rational exponent means. Rational exponent is the same thing as a fraction exponent. We're first going to talk about notation, how we write. First off, number 1, the nth root of a. Nth root of a is how you would say that in words, is called radical notation. And I see my radical right here. And again, out loud, nth root of a. 2, we could say a to the 1 nth. A to the 1 nth power. So think about it this way. If this was like 1/3, a to the 1/3 power. If this was an 8, a to the 1/8 power. That is our rational exponent notation. Because, remember, rational exponent means fraction exponent. I have a fraction exponent, which is why this is called rational exponent notation. And some of us may have seen this in Algebra 1, so I'm going to make a connection here. Put it off to the side. Square root of x. How could I write that as x to a power? Well, we call this a square root because there's an invisible little 2 right here. This is x to the first power. So if I were to rewrite the square root of x as x to a power, it's x to the 1/2. So this might be a recall for some of us, or this might be a new idea. Either way, it's very important to write down because it's the best. I always used it as like a memory tool for where that 1/2 comes from. I know that this is the square root, and this is technically x to the first power. And we'll be looking at more of that soon. We have one more notation to talk about. So we've got the nth root of a raised to the m power. And I'm stressing how we say it out loud, because if we say it right, it helps us to write it correctly. Nth root of a raised to the m power. Well, let's see if we can use some of our properties up here to rewrite this a little bit. So let's see. I can use the fact that it's the nth root of a is the same as a to the 1 over n. And that connection can come from our prior knowledge here, that by definition, for example, when I have the square root of x, that equals x to the 1/2, where here I have the power and here I have the root. This is still being raised to the m, and using our power of a power rule, we can multiply that and we get a to the m divided by n. So the important connection is that this is connected to this. And I'm going to rewrite this huge, because this is going to be one of the biggest pieces of learning today. So if I look to make sense of what this is, I come back over here. This was the nth root. Nth root. So that means that n, here, this denominator, is always the root. The denominator of the exponent is always the root, and m started out as the power. So here, m in the numerator is always the power. And this is always true from today forward for us. Whenever we have a raised to a fraction, the numerator is always the power, and this is the root. So just looking at this, if I know this definition, I know it's the nth root of a raised to the m power. It's exactly what I just said here. Nth root of a raised to the m power. And these properties will definitely start to make more sense when we start using them. But we first need to get the notation on paper first. So those are our three properties. I'm going to pause for a second because some of us are thinking and reflecting on what they just wrote. I will add one more note to this, that this could be written as so the power m could be outside or it could be inside. And why that works, the proof behind it is something we could talk more about if you'd like to see why. Otherwise, we can take it as a fact that power m could be inside or outside the radical sign. And I almost said square root, but it could be a different root. So just inside or outside the radical. So let's look at some examples. Let's start with 64 to the 1/2. From this point forward, I'm going to do a little brain bubble. As soon as I see x to the 1/2, I want to make a connection. Root power. So x to the 1/2 is the same as the square root of x to the first. Root, square root, and there's my power. So square root of x to the first power. So here, 64 to the 1/2 is the same thing as the square root of 64. And I know the square root of 64. Square root of 64 is 8. So our mission today is to start getting more comfortable moving between these two notations. Number 2. 5th root of 32. 5th root of 32. Let's learn how to use our chart, the chart you just filled out. We're actually going to be using the chart backwards. So let me show you what I mean by that. So you have this on your notebook, and I'm going to go back to the chart. I know that I'm looking for a 5th root. So what I'm going to do is I'm going to go to my x to the 5th column, and I'm going to look for 32. Down, down, down. Oh, look, here's 32. And then I look straight across, and I see 2. That's my answer. So again, I was looking at the 5th root of 32. That means what times itself 5 times equals 32. So my perfect, if I can write that a little smaller, my perfect fifths are in this column. And perfect fifths might sound weird. What if I said perfect squares? See, these are my perfect squares. That's something we're very comfortable with because we've seen that a lot. But there's more than just perfect squares in math. we have perfect cubes, perfect triples, perfect fourths, perfect fifths, sixths, sevenths, and eighths. So here's my list of perfect fifths. And here's 32. So that means that there is a whole number that when you multiply by itself 5 times, meaning 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4. 5 2's multiplied together gets me 32. So the fifth root of 32 is 2. Coming back to our notes. And I'm done. Let's look at number 3. 216 to the 1/3. 216 to the 1/3. So again, recall the denominator is my root. So if it helps you to mentally think of it this way, this is the third root of 216. Technically, the power is 1. So I could write 216 to the first power, but that doesn't actually change anything. So this is what I mentally want to think of, because now I know I'm going to go to the x to the third column and look for 216. So let's do that. Let's go to our chart. We're going to go to the x to the third column and see if we can find 216. And I'm looking and I'm looking and I'm looking, and there's 216. I look across, my answer is 6. So to make a connection to prior knowledge, we're all comfortable with the fact that 6 squared is 36. So that means that the square root of 36 equals 6. But we're going to start looking at more than just perfect squares and square roots. So for example, this one asked us to look at a third root. We had to find the third root of 216. The third root of 216 is 6, because if we were to work backwards, 6 to the third equals 216. So it's this information right here that's held in the chart for us. The chart holds a list of perfect squares, cubes, fourths, fifths, well, some fourths, fifths. You're not responsible for the grayed out boxes. But this is where the chart will help us to know those facts. It helps us to know that 6 to the third is 216 and find this out quickly. Let's see. Let's do a couple more to help us continue to practice. So number 4. 32 to the 4/5. And I'm going to move that down a little bit. 32 to the 4/5. When in doubt, label. This is my root. This is my power. So 32 to the 4/5 is the same thing as saying the fifth root of 32 raised to the 4th power. There's my root, power. You don't have to write what I put in green, but if it helps, do it. Fifth root of 32 to the 4th power. So let's see if we can break this down a little bit. Using my chart, can I take the fifth root of 32? Well, let's see. Let's go look at the chart. So, I forgot what we were looking at. Hold on. Let me go see. Sorry. Fifth root of 32 means I'm going to go look at the x to the fifth column in the chart. And again, you don't have to write that down, but I'm just putting it there in case it's helpful. Fifth root of 32, I'm going to go look at the x to the fifth column. So I go to my x to the fifth column, and I'm looking for 32, and there it is. So the fifth root of 32 is 2. So I go back to my question, and I can now rewrite the fifth root of 32 as 2. But we're not done yet because we need to do raised to the fourth power. You can either use your chart to know, or know that 2 to the fourth is 2 times 2 times 2 times 2, which is 16. So the way that you would use your chart for that, for 2 to the fourth, if I go back to the chart, 2 to the fourth is 16. So I started with the base, 2. I'm not looking for 2 squared. I'm not looking for 2 to the third. I'm looking for 2 to the fourth, which is 16. So number 4 is all done. Let's look at number 5. Number 5 says the fifth root of 243 raised to the third power. I want to rewrite this. I'm going to say that my directions here are rewrite and simplify. So here I started with rational exponent notation and I rewrote it as radical. Here I have radical notation. So how would I transform this into rational notation? Well, I know that for sure my base is 243, so I'll put that down first. The question is it the power up top and then the root, or the root and then the power? Let's go look at our notes. Let's scroll back up here and look at this super important box that if it's not highlighted, highlight it. Power up top, root in the bottom. One student one time told me that it helped them to remember P comes before R. So power divided by root. The root is always in the denominator. So let's see, this was the fifth root. So 5, oops. And 3's up top. 3/5. Root in the bottom, power in the top. Or you could say power in the top, root in the bottom, however it works. 3/5. Power divided by root. So I successfully rewrote it. So that checks off the rewriting. But for me, mentally, it's easier to think about simplifying this. So yes, I can do a little mental check on rewrite. But in terms of actually simplifying, I'm going to come back and look at this. So let's go to the x to the fifth column again, because this is the fifth root. And let's go find 243 in that column. So I'm here at my x to the fifth column. I'm looking for 243. There it is. So the fifth root of 243 is 3. Coming back over to our notes. This would be in parentheses 3, because the fifth root of 243 is 3. But I still have to address the third power. 3 to the third, 27. And we're done. Number 6, we've got 256. I'm going to write that a little lower. 256 raised to the negative 3/4. Always look at the denominator first, because this is my root. So to rewrite this, that is going to be the fourth root of 256 raised to what power? What's the power? The power is -3. So I've done my rewrite. If you're just told to rewrite, check. I successfully rewrote from rational exponent notation to radical, but the directions also say simplify, so we have to keep going. So I see the fourth root of 256. So what column am I going to go look for? Well, it's a fourth root, so I will look at the x to the fourth column. Let's go to our chart. Here's x to the fourth, and we need to find in this column 256. Bingo. There it is. So the fourth root of 256 is 4. Let's go use that information. So this inside piece I can now write as 4 because the fourth root of 256 is 4. And then this is still to the -3rd power. So now let's work on 4 to the -3. From our practice with exponent properties, we know that this needs to move to the denominator so that we do not have a negative exponent. And then you can either use your chart or your calculator or your brain to know that 4 to the 3rd is 64. So I can write this as 1/64. Again, because 4 times 4 times 4 is 64. Last example for today. 8/27 raised to the -2/3 power. And as soon as I'm writing this, I'm sure there's people that be like, oh my God, Miss J, this is crazy. But no worries whatsoever. We have all of the properties and tools in our toolbox to do this. So no matter what this looks like, this is a power that I can send into this fraction. So power of a power says that I will apply this to each term. So that's going to be 8 to the -2/3. I send it into the numerator and to the denominator. Now we're going to address what? What are we thinking? I'm going to give you a second to look at it before I recommend a path, because there's many right ways to get to the same answer. I'm looking at 8 and I'm looking at 27. The strategy here is, can we rewrite 8 somehow? 8, I know, is 2 to the 3rd. And that is something that will come with practice in terms of a strategy. But for the purpose of notes, this is purely notes. I do not expect number 7 to be prior knowledge. So don't think by the time we finish this that it's like, oh, I was supposed to know. No. Nope. This is new notes, new learning. This is a new strategy. So I rewrite 8 as 2 to the 3rd. That is still being raised to -2/3. 27, I know I can rewrite as 3 to the 3rd. And that is still being raised to -2/3. So I took 8 and I rewrote it as 2 to the 3rd. And then I took 27 and I rewrote that as 3 to the 3rd. So I haven't actually changed any value. I've just rewritten it. Power of a power, we multiply. So 3 times -2/3 is -6/3. And 3 times -2/3 is -6/3. All I did was multiply these powers, here and here. The bases stay the same. This is still base 2. This has a base of 3. -6 divided by 3 is -2, so that's 2 to the -2. Here, that also is to the -2. We don't want negative exponents, so let's see what we can move. This term will move to the denominator. This term will move to the numerator. So this becomes 3 squared divided by 2 squared. Oops. Which is 9 fourths. And I'm done. So number 7 is very much using some properties that we've practiced these past couple days with, for example, sending in a power. This idea of rewriting 8 as 2 to the third and 27 as 3 to the third, and what we did from that point forward, that is our new learning that we're going to continue to practice in class tomorrow. So this does end our notes. You do have the homework worksheet that you picked up along with the chart. If you would like to start practicing, numbers 1 through 12 on that handout, that would be great if you have time. Otherwise, no worries. We'll be working on that practice in class tomorrow. Have a great day, guys.